要多说话要少说，形象个头都要好。人多说力量大，说喊两声你拍两下。跳！要多说话要少说，形象个头都要好。人多说力量大，说喊两声你拍两下。跳！
Procedure to design machine fast by assembly. This 5-axis 2-station machines is developed from 3-axis 2-stations water jet cleaning machine combined together with 5-axis cantilever cleaning machine. Based on the design of 3-axis 2-station machine, only take the Y, the Z, the B, the C, and the tool from the 5-axis water jet cleaning machine. There are 3 parts we have to separate from 3-axis 2-station machine. The first one is the X component. Next is the foundation, and the third is from the left parts from the water tank, or the left fender, right fender, the stand of ABC, turning table, and window, and the mechanism all be included. We go back to SolidWorks to see how to do it. We started from open old file from D drive from the folder Gen file, which is the owner of a 3-axis 2-station machine. The original past file is IGS file of the mechanism. You can see all the IGS list on the screen. The m.IGS is the foundation, including the station of the first station. Name X on top of M, and the Y on top of X, the Z component on top of Y component, and beneath Z is a C component turning around Z axis, and this is 3 axis two station without C and B. The C is a turntable of the second station, and A and B turning around y-axis, and the CC is the window up and down to protect the water floating. Then, to save the lecture time, we already translate these IGS file into assemble file, and also we assemble all the components to the real machines already. Right now we just simply show the assembly file of the whole machine, which name is KH15. Open it. You can see the whole machine KH15 showing in front of us in 3D drawing. We change to the standard showing the SY. The machine face to the sky is y-axis. The Y and the Z is always mixed up in SolidWorks, so we have to turn the whole machines around the x-axis according to the right hand rule 90 degrees to justify the machine. Before doing that, we have to understand whenever turning around the axis 90 degrees, the whole information X, Y, Z, A, B, C all changed. You cannot take the original back, the old situation back, because the relative data structure inside SolidWorks. This is one notification. Another one is, suppose the M, you can see the biggest, including the machine stand, water tank, the structure, the support of ABC turntable, the left fan, the right fan. The three parts we have to separate according to this drawing. The first one is x-axis component, this one, X. The second is the foundation of the first control. The third is the left parts from the water tank. All this has to be separate as the foundation of the control machine, the second station's foundation. The three part has to separate from this joint. If we get this one, you cannot get the left parts. If you get left parts, you cannot get the right parts because of the relative data structure. In this case, we have to copy the same data into two file folder. Right now we are in Gen file folder, and we prepared another Gen file new, the same. The purpose is to separate the left parts since from the water tank. Okay, let's continue. Started from the simple one, this X component. If from S component we'll remove all this, leave X only. Okay, before we doing that, we'll see the machine is in wrong situation. You have to turn X-axis 90 degrees to late the machine. On the plane is SY and the top is Z coordinates. So we have to turn the whole machines 90 degrees about X-axis. How to do it? First of all, we have to let the fixed be removed. How to do it? Just simply put the cursor on it and press the right button and choose floating. You can pick all of them and do it in once or one by one. Not too much. One by one, take not longer. Okay, finished. Then, how to let all the machines turning once? Simply press the left button on the left top position and keep pressing and pull the cursor to the left button and release the finger. Then choose rotating the component and choose the function from delta XYZ and the parameter delta X input 90 degrees and adopt and before make sure we have a look. This is SY, the Z point to the sky. That's correct. And OK. In this situation, it's better have a saving. Then we save another new file, save and not calculating. Give another name. How about KH15A? Differentiate from KH15 and save it. After save KH15A, the whole SYZ ABC, you cannot expect to locate at the original position, original situations. Just simply forget KH15. Then we're talking about to separate X component. Then we have to remove from Y to C and also M and press the delete key of the keyboard and select remove all. Only left X on the screen. This X component shall to be loaded to join the new machine's assembly. So we need assembly file or PRT file of the SolidWorks format. Then we have to save another new file, right, in ASM. OK. And we give the name of X component. How about to give X2 to create S2.asm? OK. So the S component be saved. Then we close the O file to clear the screen and reopen KH15A to separate the state of the first control. Not calculating. close. Okay, we remove since X to CC. Only leave M on the screen. Press the delete key of the keyboard. Remove all. Close. So you can see the M including all of them. Then we have to remove from the left part. Right now, turning to leave the right part since the water tank to leave the station on the screen. Fortunately, all the component is in sequence. You put a cursor on input 1, you can see the highlight in here, input 2. So in this case, we're sliding the machine along the input number to see which one is the end of the station. 19, 20, 21, 22, 23, 24, 25, 26, 27, 29, 20, 29, 30, 31, 32, 33, 34, 35 until input 41. How about the input 42? 42 water tank already. So we have to remove, to delete since input 42 until the end. Okay, so from water tank input 42 until the end input 65, and press the delete key and choose remove, delete all of them on the screen. Only the support, the stand, the machine stand leave on the screen. This is what we need. We have to save it as a style of assembly to support. It's supposed to be loading to join assembling the new machine. So we save another file. The style is .asm. The file name, how about to give to create mm.asm. Okay, save it. Save all. So these two ASM saved already. Then the last one, the third one, we have to prepare the foundation of the controller second, which is located in Java new. We already talking about. Okay, clear the machine, clear the screen, and open old file from D drive. The file folder is Java new. Open it. The same, the IGS file on the same. You can see M, you can see SY, Z, A, B, C, and CC, and the important IGS is M. We already translate the IGS format m.IGS into m.asm. Let's see the m.asm. Open it. No calculation. Close it. And put on the standard SY standard position. Oh, fortunately, the machine already been removed. Okay, we do it again to show in more detail. So close the file and open this file. Open Genfile new and show IGS file. Pick m.igs and open it. From the very beginning, we will show how to remove the station of the controller 1. In this video, we see already from the first input to the input 41 all belong to the controller 1's station. So after this transformation, we turning the M component around the x-axis 90 degrees to let it located in right situation. Then we can remove the input from the first one until the input 41 to remove the station of the first controller, to leave water tank mechanism, the left fan, right fan, and the support of ABC component. This is what we need. And then we can save assembly file as well as the IGS file, which will be used later on polychance for X file creating. Okay, the transformation m.igs into the SolidWorks local area is almost done. Okay, you can see the M on the machine, XY in wrong situation. You have turned the machine. Simply pick it and choose the turning component and choose the function from delta XYZ, and the delta X press input 90 degrees adopt. You can see it is okay right now. Just okay. We save it first. Save another new file. Save no calculation. And give the new name M3 to differentiate from M. Save all. Now we are ready. Extend to see input 1. We already know from input 1 until input 41 all belong to the station. So we remove it from input 1 up to input 41. After highlight, we just simply press the delete key of the keyboard and choose the delete all of them function and shut down. You can, on the screen, you can see the third part geometry on the screen only. This is what we need. we still save assembly file first by the file name m3.asm, and then the most important is we have to get IGS file. Then use the function save another new file, the style give IGS start.igs, and give the file name m3 file named m3.igs will be created. Okay, so the third IGS file created after the X component ended the station in position. Then we still have to output these two components IGS file. Then the system is handling the IGS files creation. Okay, done. Then we close the screen, clear the screen, and doing the arrangement of X component as well as the station from 3-axis to stations machines. The name is S3, S2 as well as MM. We open the O file from the 5-axis cantilever water jet cleaning machines. The file folder is located on D drive. The folder's name is RH-IGS. Open it. And the original machines, the whole machines in assemble situation, we have the name is RHASM old. We open the 5-axis original old machines file name. You see the location SY. Everything is in good condition. Then we use insert parts to insert the X2 and MM from Genfa file folder. The first we see on the screen is MM. So to put MM, press OK, make sure OK. To put the station on its original position is C much closer than the home point, these points. And then insert parts, the X2 from Genfa file folder, which prepared already. S2, open it, and only press OK. So these two components in. The width of the track is all the same. The difference is the length. This is 3 meters. This is supposed about 1.5 meters. And the Y, the X components provide the Y track. The old one of the 5-axis cleaning machines is longer, much longer, which is not what we need. So we use the new one. While these parts, Y component, Z component, C, B, and the tool still using the 5-axis water jet cleaning machines. Okay, we have to do arrangement this and this to upper main and move these two components to the left. The Y don't move, keep in the same position. How to do it? We have to catch the coordinates on the screen and doing some calculation to get the moving distance. How to do it? Then we started from Z first. This point should move to here, so we get Z component of the coordinate first. So put a cursor, you can see the highlight orange circle and press the left button. You can see its Z is 1311. And how about the original Z position? Original is 105.35. So 1311 minus 805.35 is 505.65. So the Z of this component has to be up 505.60.5 millimeter. And how about the X? Then from here we can see the X is minus 170.6 millimeter. And how about here? Showing minus 17.5. So the difference from the 170.6 minus 17.5 to make 153.1 millimeter. X has to move in positive direction. So the delta X, delta Z, we get it. Now we can do adjust these two components in once. How to do it? The same. We have to remove the fixed to floating and then pick MM as well as X2, these two all together, and choose the function, turn in the components, and choose the function from delta XYZ. We get and input the calculate delta for delta X 153.1 and 505.65. And adopt. We use the wrong function. Don't worry, just go out. Here is a recover function. Press the recover function, it will get back to its original position, and then do it again. Don't forget, now the turning only shift the component by this function, and by from data xyz. The data x is 153.1. The data z is 505.65. Okay, adopting and okay. You can see the new machines in these parts. This and this has to be removed. But we don't remove it, we just keep it. But save these situations by the function save another new file, save and no calculation. The new file name, how about to give phasm1? Save it. Okay. Then what we want to do next is to get IGS file of x2 and IGS file of the new position. How to do it? We started from S2. Remove this one until Press delete key of the keyboard. Remove all of them. Leave S2 on the screen. Then save another new file, SM, okay, and give a file name. How about RHS3? From S2 to change to RHS3 ASM. Save it. Then the most important is to save another file by using IGS start.igs style. The file name still RHX3. Okay, save it. Yes. Done. Then we save close the old file, clear the screen, and we save the old home machines RHASM1 already. We load it back. No calculation. Then we'll leave M on the screen. But we have to see one thing. The floor at here. Right now the stand is up. We have to generate a support under the station. We have to do the support first and then combine the stand and the support together to create a new foundation of the new machine. How to do it? We have to clear the screen and open a component. Okay. And set the SY standard surface and open the sketch function and using the coordinates, but we don't know what size of the machine. Therefore we have to go back to open the old machine RHASM1 and to make a measure from the screen the S data X, data Y, data Z of the supporter. The Z is from the height the button to the button. Let's see. the coordinates in z. This z is minus AA2. This z is 3 minus 396. So 992 minus 396 to make 4A6. The delta z is 4A6. We write it down. And in y distance is from here to here. This is y353. And how about this one? 993. 993 minus 353 to make 6040. So delta y is 6040. We mark it already. So about the x, this position in x is 903.15 in positive. And how about the end of x? To get the x position of these coordinates become negative 1046.85. So 903.15 adding 1046.85 to make 1950 millimeters. This is delta x. So we know delta x, delta y, delta z already. So we close the screen and open a component in blank and choose the standard SY surface and choose the sketch function and use the square function. The x is longer than the y. To leave the press the finger. Then use intelligent scale function to put the cursor on the horizontal top line. Orange line highlighted. The cursor on top of it. Press the left button to pick it and release the finger and move to the top any position and press the left button again. Then input 1950. Then press the enter. And the vertical as well. Put the cursor on the left margin and orange highlighted and press the left button to pick it. Move the cursor to the right any position and press the left button and then input 640 and press enter. Then we get the section of the supporter. Okay. Then we have to generate the geometry of the supporter. Pick the sketch 1. Choose this function and choose its tension function. The default is 10. We have to give the z 4A6 delta z 4A6 millimeter and press enter. Okay. So the supporter created. We leave the color like this, no matter it's ironed or cement or belong to these colors. Okay, we have to save it for later on assembly. we save another new file. The style is .prt. The file name, how about to give block? The block.prt created. Now, okay, after this created, we clear the screen and then open an old file, prhasm1. Open it. No calculation. Then insert a component. The component's style is PRT. And then the name is block. Open it. And put the component at its original position. You can see this is original position. So we have to move down to here. So this point be here. The easy way by calculation is how about to let this point the same, the SY the same as this one. Then we lower down the Z by two process. This is 0, 0, 0. We don't need to calculate anything, but here we have to see the x minus 1065.84. Not 84, 85 millimeter, and the Y 993 millimeters. We're doing this too. Use these two values to move the component first. We have to cancel the fixed marking by floating first, and pick the block, and by using move the component by using from delta SYZ, we talk already, we'll move SY first, then Z. The delta X we calculated already, move X to minus 1046.85. The delta Y 993. Okay, adopting. You can see the SY in position, but Z difference. Okay, the first time. So the second time, this one has to be here. So how about the difference in between? Okay, to see this one first. This is Z is 4A6 in positive, while this one is minus 396. So the moving distance is 396 plus 4A6 to make AA2. But in negative direction, the delta Z must be minus AA2 millimeter. Okay, we pick the block, move the component by the function from delta SYZ, and the delta Z give minus AA2. Adopting, and you can see. Okay, then the new machine created. Then we save this situation, save another file name, save and no calculation. we give RHASM2. Save it. Then we have to output the stent, the new stent. We have to remove from here to here, and X2 as well, to leave MM and block on the screen. Then press the delete key of the keyboard. Remove all of them. This is the new stent, what we want. Then save another file, save ASM file first. I'll give the file name how about to give rhf3.asm, and then save IGS file by using save another new file. The style of the file, choose IGS start.igs. The file name rhf3. Save it. Then the third IGS file created. Then we leave SolidWorks. Go to Polytrans to translate these three IGS file into X file. So go back, go to Polytrans. We started from the last IGS by using input 3D geometry, by using IGS v5.3 via Okino ASCII file function, and choose the right file folder from D and RH-IGS file folder, and from RHF3 IGS. Okay, open this old file. Okay, yes, start Scene Optimizer. Start. The Polytrans are translating. Okay, the model display on the screen, RHF3. Then we save the S file in positive direction by exporting 3D geometry, the direct S file style. The positive direction is 2, not picked. Okay. The folder rh.iges. The file name, give rhx a, give 2a, rhx3aa. Save it, and then save the negative parts of the geometry triangle surface by export 3D geometry in direct S file format. We have to pick reverse orientation of all polygons and normals, and we have to pick flip polygon normals. Okay, and give the file name rhx3bb. So the negative X file out. Then we have to combine the positive parts and the negative parts simply by reset scene negative first, and then import 3D geometry in the S file format. The file folder to open D drive. RH-IGS. The positive name RHX3AA. Open it. OK. Yes. RHX3AA in. The positive parts in. And import 3D geometry in DirectX file format. And RHX3BB. Open it. And OK, and yes. The positive and the negative both showing on the screen. Then we combine the positive and the negative triangles geometry model and output into a single file by using export 3D geometry in DirectX file format. We save the positive only. OK. And the file folder rh-igs. The file name they give rhx3 only. Press enter. Then the supporter, the station of the first controllers. The name is rhx3.x created. Then continue to do the next one. Recessing negative. Import 3D geometry IGS v5.3 via Okino ASCII file from the D drive from rh-igs file folder. Right now, the new X component rhs3igs. Open it. OK. Yes. Start Scene Optimizer. Start. Yes. OK. Then save the positive parts of the geometry triangle surface by export 3D geometry in DirectX file format. The positive first. OK. The file folder correct. Then we'll give a file name rhx3AA. Press enter. Yes. And then the negative export 3D geometry in DirectX file formats. Pick reverse orientation of all polygons and normals, and pick flip polygon normals. OK. And rhx3 BB. Enter. Yes. OK. After these two created, we have to combine it by recessing first negative, and then import 3D geometry in DirectX file format, and the file folder to pick the D drive, and from rh.igs. The file name rhx3AA first. The positive component of the X component on the screens rhx3AA in. And then import 3D geometry in DirectX file format rhx3BB. Open it. OK. Yes. Now rhx3BB in. the positive and negative both on the screen already. Then we export 3D geometry in direct S file. Output the positive only. Okay. The file name RH X3 and press enter. Yes. So the S component, the new S component, X file created. Then the last one, reset scene negative translation, import 3D geometry from the function IGS v5.3 via Okino ASCII file. The second component's foundation is from D drive, and the file folder is Genfa new. Open the old file. The file name is m3.igs. Open it. Yes. Start Scene Optimizer. Start. Yes. Okay. The geometry showing on the screen. Then the positive out by export 3D geometry in direct S file format. Okay. The file folder, we choose the D drive and the Genfa new. Open it. The file name M3. We give M3AA. M3AA and press enter. Then output the negative by export 3D geometry in direct S file and pick reverse orientation of all polygons and normals and pick flip polygon normals. Okay, and give a file name M3BB and create it. Then combine the positive and the negative components by recessing negative and use import 3D geometry, the S file format, and choose the D drive and the Genfa new. Open it. The positive is the file name is M3AA. Open it. Okay. Yes. M3AA in. And then import 3D geometry in the S file formats. The negative name M3BB. Open it. Okay. Yes. M3BB in. And combine them to save the file in the file folder by using export 3D geometry in direct file formats, the positive only. Okay, the file name give M3. Then M3.x will be created. The third X file created. Then these three X file have to be copied into CMS CAPP's data file folder by using the system in D drive. The last one first, the Genfa new M3. Where is M3? Okay, M3 is here. M3 X file is this one, and copy this one and go up to the D, to the D's CMS GAC, and the data file folder, and find a free space past and replace the old one. Then M3.x, the new one, in, and then go back to the file folder in D drive rh-igs. Two X file has to be copied. The first one is rhf3, the foundation. rhf3, where is it? rhf3 X file, that's it. Okay, one by one. The foundation first. Press the right button and copy, and then to CMS GAC, the data, and press the right button and paste the file and replace the old rhf3.x, the new rhf3 in, and then go back to D drive and go back to rh-igs file folder. And how about the X component named rhs3? Okay, here rhs3 in S format. Press the right button and copy it to the D drive CMS GAC, the data file folder, and paste. Replace the old rhx3.x, the three new one in. Right now, the challenge procedure coming. How to create the scene CSV file based on 3-axis 2 station is KH33. We see it first. 2 machine. The first station started from here and to the continue in here is 6. This is the first controller. The second controller from here to here. The second one is only thing we have to change the dummy into M3. That's it. It seems simple. Okay. And the first controller, we have to go back to 5-axis cantilever water jet machines to see in there. We separate into 2 controllers. This is controller 1, this is controller 2. and we can combine the controller 1 and the controller 2, these two stations inside CMS CAPP program. Okay, in this case, we leave and save KH33, save another file in here, and change the file name, suppose to KH3AA. Then we open KH3AA to remove the first controller by pressing the right button and delete, and the first one to change to M3, and should open it. The rest all keep the same. ABC limitations marked here already. C2, B2, A2 all belong to the original one. Okay, then save. Yes. Cross. Yes. The file name KH33AA. Save it. Yes. Okay, after saving, we see the controller 2 first. How to see the controller 2 first? Reset. New. Remove the screen. And the controller 2, we have to change the 1. Become 2. And the scene input, name of scene, to input KH33AA. Open it. You can see the controller 2 of the new machine, and 3 axis. This is a window. 3 axis in teach mode. We can see the J1 is C axis rotating, the J2 is A rotating, J3 is B rotating. It's okay. So the second continue. Okay, now. Then we go back to the file management system. We started from RHN, the 5-axis machines, original CSV file. How about let's copy first? Copy to a new file name. Change the file name to RHN AA. Enter and open this controller once. We know the foundation be changed to RHF3. The object 0 mesh 0. The X component be changed as well to RHS3. Okay, that's it. The Y, Z, C, B leave the same as original one. The limitation, just leave next step to do it. But the new methods is to give dummy.x. Okay, dummy.x. The two are the same. While the new one, we use the new definition, better xorg.x. yorg.x. zorg.x. The tool we have to move in front, but later on. Let's do it later. The tool object 11 attached to object 5, the B component. So in this situation, the RGB has to attach to 5 as well. While the transrotate have to write the spatial 99 number, then the system will know how to put the RGB on the tip of the tool. So this is new definition, but we have lecture already. It's better to move the tool in front. 0, 1, 2 and 3 is the tool. So we have to adjust the mesh 11 changed to 6, and this one has to be changed to 7, 8, 9, 10 and 11. 7, 8, 9, 10 and 11, and copy and move to line number 8, and move these to line number 14. That's it. This is controller 1. We find out from the system the limitation, then we fill in here. The C we always give 540, 1.5 turns, minus 543. The B 91 to minus 91 is okay. So we save it first. We measure the XYZ only on the system. So we save this situation first. Save, save, save. And into CMS CAPP program, new, in the control 1, input name of scene, RH NAA, open it. This is control 1, new machines. We try to see the moving and to decide the limitation of the SYZ. In S direction, in this direction, the tool seems at the middle. So we move to the right first. In teaching mode, J1, 10, 20, 50, 100. This is all limitation, all the limitation. So we let the limitation be opened and continue move to 200, 300, 400, 500. Okay, just positive 500, negative minus 500. We mark it first, then we add it in once. So how about the y? Reset. The y is J2. How about the positive? Positive 100. And how about the negative J2 minus 200, minus 300, minus 400, 500. Okay, positive 100 minus 500. So how about the z? J3. J3 positive 200. Okay, just 200. So the z positive 200. So the minus you say first. J3 minus 100 minus 200. Okay, positive and a negative 200. So we go back to Excel file, this one, to give the right limitation. How can we know this is the first J1? The 4 minus 3 is 1, is first axis. So x is positive 500 minus 500. The y positive 100 minus 500. The z positive 200 minus 200. That's it. Okay, save it. Yes. Red cross. Yes. File name RHNAA. Save it. Yes. Now go back to CMS CAPP program. New. And the controller 1. Name of the scene. Reload RHNAA in. And if you want, you can, by using teach mode, the X moving to see the attachments is okay or not. The Y going to the negative direction. The Z going up. The B turning around the Y-axis. The C turning around the Z-axis. It seems everything is okay. Is set. So how about the second controller, 2 station? Change the number control station to number 2. Scene input, length of scene. We prepared KH33AA already. Open this file. Okay, in this case, the controller 1 and the controller 2 both in. the machine down. We save by using scene output. If we still want to keep this viewport, we have to save view first. Then scene output. The new file still in CMSGAC data. The file name supposed to give KH33 and RHN. They combined these two machines to create the new file name. Then we can see from here the new file name is KH33 RHN. Let's open it to see the combination, these two files. This is the first machine controller up to here. The station RHF3, the X component RHF3, a viewport translotate 10, mark here. This is YZCB2, all use the old one. The new limitations, the RGB is 99, while the second station's RGB give 98. That means don't show the second station's RGB on the screen. And CB2, C2, B2, A2, CC, all the new one, all the old one. So everything is okay. So this is before ending, we can see this is the 3-axis 2 stations procedure. If we don't use the B and the C in these situations, we can run the input script the same as 3-axis 2 stations machines. By these 5-axis 2 stations machines, okay, we run it and until the ending by PLC modes. And press use PLC 1. By pressing the procedure 1, the program will start it from the first one, the C turn 100 in, and next one until the last one, and go back to the first one. Run and run until the end of the day. Okay, going.
Everybody fucking talk！ 钱要多说话要少说，形象个头都要好。人多说力量大，说喊两声你拍两下。跳！要多说话要少说，形象个头都要好。人多说力量大，说喊两声你拍两下。跳！要多说话要少说，形象个头都要好。人多说力量大，说喊两声你拍两下。